Welcome back, friends. As we promised in our earlier session, that today we are going to have a idea or about process flow, about gradient descent, that how it is work logically, and followed by we will have an idea about that process that need to be taken mathematically. So let's start today's session. Okay. So suppose let's start with an example. Let's suppose you are basically you are basically at the top of a hill in some day. Okay. And you basically need to go to the next top. But what is the problem? There is a high or dense fog. Then how can you choose your path? Because if you are choosing wrong path, then you are going to fall, or there is a uncertain incident will be happen. So in this situation, the best possible way is you need to follow the path where your feet want to go. That that's mean that, for example, that you are going to take steps for in the dense fogs situation, then you need to follow the steps. Other than that, just go go blind here and there like a headless monster. So it's like a ocean. So in the ocean, for example, if you've lost in an ocean, then you take help of compass. Similarly, here your feet will work as a compass. Okay. So suppose you lost in the mountain in a dense fog, you can only feel the slope of the ground below your feet. So the good strategy is to get the bottom of the valley quickly, reach to the end point, and then again go up to the hill and reach to the destination point. So this is basically uh, this uh, so this basically the gradient descent is doing. So if you see that in this picture, you can see that the gradient descent will follow the step, go to the local minima, and then check that whether it is a minimum or not based on the vector parameter, that is theta. So what is theta? So let's again give you an idea. So theta, if you see here, if you see here, so 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 if this is the path, if this is the path, so theta is nothing but this. This is the theta. That what is the angle with the slope. So this is exactly what gradient descent does. It measures the local gradient of the error function with regards to the parameter vector theta, and it's go in the direction of the descending gradient. So whenever it goes here, and if again calculate the gradient, so this is theta for say 2 and it is theta 1. So it's surely evident that theta 2 is less than theta 1. Similarly, if it is go here and again it check for the slope, check for the slope, then what will happen? Then the, this slope theta 3, so theta 3 less than theta 2 less than theta 1, like so on and so forth. So and once the gradient is basically 0. When it is here, the gradient it's followed to the x-axis, and if this is the gradient theta n, so theta n less than theta 3, theta 2, theta 1, and theta n is basically 0. Okay, so instead of climbing a hill, thinking of gradient descent as hiking down to the bottom of a valley is the good strategy. So the better, so the so it's better. So this is basically a better analogy because it is minimizing algorithm. So it's minimizes the given function. Okay, so that's all for today's session. Let's have a quick look with our next session, which is so where basically we will go with the uh, mathematical steps that need to be followed and what are the other uh, parameters which is going to calculate for this calculation. That's all, guys. Thank you. Stay tuned. We'll meet you in the next session very quickly, and please subscribe so that you will get the updated videos uh, in a in a faster way. Thank you, guys. Bye bye.